Today's lesson is about multiplying and dividing decimals. We're going to talk about the rules for multiplying and dividing decimals and how they're different from adding and subtracting. We're also going to learn how to estimate to make sure that our answers look correct when we're finished. Let's get started. Here's the first problem. So we're going to find the product or quotient. If we're doing a multiplication problem, remember that the product is the answer to a multiplication problem. So here we're going to estimate to see what our answer should be close to. Here's how you can estimate. There's different ways to do this. As long as you estimate correctly or don't get too far away from the original numbers, you'll have a good idea of what your answer is going to be when you're done. So here, what we know is that 4 5/100 is about 4, because it's close to 4, and 2 1/10 is about 2, because it's close to 2. So we can use those two numbers, 4 and 2, to find the product of our estimate to see what our answer should be close to. Here, 4 times 2, I know you guys know your times tables. 4 times 2 is 8. So what that means is that 4 5/100 and 2 1/10 is going to be about 8. It's going to be a little bit more than 8 because 4 5/100 is a little bit larger than 4, and 2 1/10 is a little bit larger than 2. So our answer can be a little bit above 8, but 8 is a good estimate. Why don't you try estimating these two problems here? Hit pause, estimate, try to get an answer, and then see if your estimate is close to mine. What I did here in question 1 is estimate 5 2/100 to 5 and 3 9/10 to 4. And I multiplied 5 times 4 to get 20. So the product that I found as an estimate is 20. So what that means is that 5 2/100 and 3 9/10 is about 20. For the second problem, I estimated 7 98/100 to 8, because it's close to 8, and 4 7/100 to 4, because that's close to 4. And I did 8 divided by 4 to get 2. So the actual answer is going to be about 2, somewhere close to 2. When you estimate with division problems, one thing to keep in mind is that you want to try to estimate and create a problem that's going to give you a whole number answer. Division problems can have remainders, obviously, so you want to try to avoid having that. So try to find numbers that are close to each other to create a whole number. All right, so now let's talk about the actual rules for multiplying decimals. Multiplying decimals has its own set of rules that are different from adding, different from subtracting, and different from dividing. So the first rule is that you do not need to line up your decimal points. If you line them up, you can still get the correct answer, but you're creating extra work for yourself that you don't need to do. You'll have a lot of zeros in your problem that don't need to be there. So do not line up your decimal points. It will save you time, it will save you work, and it will make the problem look a little less cluttered. The second rule is that when you finish solving the problem, the number of decimal places in your math problem has to equal the number of decimal places in your answer. So you'll see in the first example, we're going to count up the places in the problem, and we're going to use that to help figure out where the decimal point goes in our answer. Okay, here's our first example problem. 3 875 thousandths times 2 3/10. So let's write that problem vertically, just like this. Notice that I did not line up my decimal points. I just wrote it the way it is. So that'll also help to remind you that you don't just move the decimal point up and down in these problems. You have to do other things, like I said, that we're going to show you about counting up the places to figure out where the point goes in the answer. Okay, so do your multiplication without even worrying about those decimal points. So here I multiply everything by 3 first. 3 times 5 is 15, carry a 1. 3 times 7 is 21, carry a 2. Or plus 3 is 22, carry a 2, and so on. So I get my first line. I get my second line. Remember to put a placeholder 0 in right here before your second line. And then I add my two numbers together. So I add them up. That's the answer I get. So now I have to place my decimal point. So what you'll notice is that in the first number there are 3 decimal places. In the second number there is 1 decimal place. So what that means is in my answer I have to have 3 plus 1 decimal places. 3 plus 1 is 4. So if I count over from the right, 1, 2, 3, 4, I put my point in front of the 9, and I have 4 decimal places after the point. So my answer would be 8 9,125 10,000ths. Right there. So just don't forget that you have to add up your two numbers. You count up the points behind the numbers behind the point, and you add them up to get the numbers behind the point in the answer. Okay, so hit pause, try out these two problems, and you can see how you did when I put the answers up in a minute. Okay, here's what I came up with. In the first problem, I did not line up my decimal points. I just multiplied everything by 9. I got my answer. And I put my decimal point in where it is because, if you notice, there are 2 decimal places here. There's 1 here. 2 plus 1 is 3, so I should have 3 in my answer. For the second problem, I actually flip my numbers around because this is a personal preference. I like having the number that has more digits on top. So this has 3 digits here. This has 2 digits. That's just how I like it. It looks right to me that way. So you don't have to write it this way. You could have written it the other way around. There's a property in math called the commutative property that lets you do that, that allowed me to do what I did. But if you wrote the 8 1/10 on top and the 22 9/10 on the bottom, that's completely fine. As long as your multiplication is done correctly, you should have the same answer as me. Your work in the middle may look a little bit different, but you should have the same answer. Okay? So, what you'll notice here is the points happen to line up. That's just coincidence. They both have 1 place after the decimal point. That's why they line up. I did not do that on purpose. But I did all my multiplying, so I multiplied everything by 1. I put my placeholder down, multiplied everything by 8. I got my 2 numbers and added them. And then I counted the places, 1 and 1. So there's 2 total down here. Okay, 1 place plus 1 place, there's 2 places total. So 185 and 49/100 is my answer. Let's do our estimating to make sure these answers look right. For this first problem, I could estimate this first number to 6.5 or 7 or 5, or not 5, I'm sorry, 6, 6.5 or 7. This one here I can estimate to 1. So let's say I estimated this to 6 and this one to 1. 6 times 1 is 6. 5 and 886 thousandths is close to 6. So it looks like my estimate confirms my answer is at least close to being correct. This one here, if I estimated this number here to, let's say, 20 or 25, and this number here to 8, 8 times 20 is 160. 8 times 25 is, let's see, 25 times 8 is 200. So it's going to be somewhere between 160 and 200. My number is between 160 and 200. So 185 and 49/100 looks like it could be the correct answer. At least it makes sense. Okay, let's move on. So now, dividing decimals. Dividing decimals has its own set of rules also. And here is the first important rule. The divisor, which is outside of the division box, cannot have a decimal point. It has to be an integer. So we have to modify our problem slightly to make that number a whole number or an integer without a decimal point. Okay? After we do that, we're going to divide, and at the end, our decimal point just goes straight up. So some things I like to tell my class about that is that the multiplication problems are the only ones where the point does not go up or down at the end. So multiplying like we just did, we have to add up the places. Dividing is kind of like adding and subtracting. You just move the point up or down. So here we're moving it up. So an example problem, 32 and 4/10 divided by 9/100. So if we set this up, think about which one is the dividend and which one is the divisor. I mentioned that the divisor goes outside of the division box. The divisor is always the one that comes second when a problem is written this way. So let's write it with the divisor on the outside, just like that. And then what we'll notice is the divisor has a decimal point. So we have to move it to the end, or move it as far to the right as we can, like I'm doing here, so that the 9/100 turns into an integer or a whole number 9. So I'll just go over this again. I move the point 1 space, 2 spaces to the right. And after I do that, my number turns into 9. The only problem is I created a new math problem now. And I have to make the math problem I create equal to the one that's at the top of the page. So in order to do that, I also need to move the decimal point for the second number over 2 spaces. So if I move this one 1 space and 2 space, it moves out here and I create an empty space here. Unless a number repeats, you always fill in empty spaces with zeros. I'm going to try to draw one. Zeros. It's a little zero. Okay, so our new math problem looks like this, and the problem at the very bottom of the page here that we just created is equal to the one at the top. Here's why. Every time you move a decimal point over 2 spaces or one space, that's like multiplying by 10. I'm going to try to write that here. It's kind of hard to write with a mouse. Times 10. So if I do that again, it's another times 10. And 10 times 10 is 100. Okay? If I move this one over 2 spaces, that's times 10 times 10. That's also times 100. So you can multiply 2 parts of a math problem by the same thing, and it won't change the outcome of that math problem or the value of that math problem. That's why we're allowed to do this. Okay? So what you need to remember again is you move both of them. The most common mistake I see students make is they'll move the decimal point out here, but they won't move the decimal point underneath. And that will not create an equal math problem. That will give you a different answer. Okay, so let's take our problem that we wrote at the bottom and let's solve it now. Okay, step by step, long division. Remember that you need to take the number on the outside and see if it can go into the numbers on the inside. So 9 cannot go into 3, but 9 can go into 32 3 times. And 3 times 9 is 27. We subtract to get 5. Bring down the next number, so bring down the 4. 9 can go into 54 6 times, and 9 times 6 is 54. Subtract to get 0. And we need to bring down our next number because we still have not got to the decimal point yet. So we need to bring down our next number. Bring down the 0. 9 can go into 0 times. And 9 times 0 is 0. So we subtract to get 0 as our remainder here. And since we hit the decimal point, we can stop. Okay? What we need to do now is move the decimal point up. So remember, the decimal point goes straight up into the problem. And if you want to, you can add another 0 after the decimal point. So I'll just write one here real quick. You can put a 0 here if you want to. So you can write your answer as 360.0. You can just write it as 360. You really don't need a decimal point here because it's a whole number. But that is how you would place the decimal point if you're doing a division problem. Okay? So take a minute, practice this practice problem, set it up correctly, put the divisor on the outside, the dividend on the inside, do your long division, move your decimal points, do everything I just showed you, and then when you're done, unpause your video and you can see if you got the correct answer. Okay, here's what I came up with. So, let's do our long division. First thing before we start, moving the points over. This one needs to move over 2 spaces. That's the divisor, 2 spaces. So this one has to move over 2 spaces. Okay, and the point would go out here. That empty space you create, you put a 0 in. So that's how I got 3,860.0. That's also how I got 12 on the outside because the point moved over to the end. Okay, so let me clear those. Do your long division. 12 cannot go into 3, but 12 goes into 38 3 times. 3 times 12 is 36. Subtract to get 2. Bring down your 6. 2 goes into 26, or 12 goes into 26 2 times. 2 times 12 is 24. Subtract to get 2. Bring down your 0. 12 goes into 20 1 time. So 1 times 12 is 12. Subtract to get 8. Bring down your 0. And what you'll notice is in this area right here, let me break my highlighter, from this point on, you're going to see that your number keeps repeating. Okay? If your numbers keep repeating down here, that means you're going to keep writing the same number up here, which means you have a repeating decimal. So you have to write your repeating decimal correctly with your line on top. Okay? The other thing to notice is that when I was finished with my problem, my decimal point went from right here straight up to the top. Okay? So my answer is 321.6 repeating, or 0.6 repeating. Okay? Hopefully you got the correct answer. If not, you can check your work and see where you made your mistake. That's the lesson for today. You can use this video, as always, to help with homework, to help with preparing for quizzes and tests. And I'll see you next time.